Welcome to our presentation on security technology, focusing on access controls, firewalls, and VPNs. Let's dive into the essential components that protect our information systems. Our learning objectives include discussing the role of access control, identifying the four fundamental functions of access control systems, describing firewall technologies and their categories, exploring firewall implementation approaches, and understanding virtual private networks and the technology behind them. Technical controls are crucial for enforcing policies in IT systems, especially those not under direct human control. They help balance the availability of information while preserving its confidentiality and integrity. Technical controls are essential for enforcing policies in IT systems. They improve an organization's ability to balance information availability with confidentiality and integrity. Access control systems rely on four key mechanisms: identification, authentication, authorization, and accountability. Each plays a vital role in ensuring secure access to systems. Access control approaches can be discretionary, where the data user has control, or non-discretionary, controlled by a central authority. These methods specify who may use a resource and how. Biometric recognition uses unique physical characteristics like fingerprints, voice, and facial geometry to verify identity, enhancing security measures. Biometric methods vary in effectiveness and acceptance. This table ranks different biometrics based on universality, uniqueness, permanence, collectability, performance, and acceptability. Firewalls are a combination of hardware and software that filter or prevent specific information from moving between untrusted and trusted networks. They can be separate systems, software services, or networks with supporting devices. Firewalls can be categorized based on processing modes such as packet filtering, application gateways, circuit gateways, MAC layer firewalls, and hybrids, each offering different levels of security. Let's explore the different firewall processing modes in detail, including packet filtering, application gateways, circuit gateways, MAC layer firewalls, and hybrid models. Packet filtering firewalls examine the header information of data packets, often based on IP source and destination addresses, direction, and protocol type, to allow or deny traffic. Understanding the structure of IP packets is crucial for configuring packet filtering firewalls. Here, we see the structures of TCP and UDP packets, which are fundamental to network communication. A packet filtering router blocks or passes packets based on a set of filtering rules, which include source and destination addresses, services, and actions to allow or deny traffic. Application gateways function as both firewalls and proxy servers, often placed in unsecured network areas. They can be protected further with additional filtering routers to safeguard internal systems. Application gateways provide a secure interface between internal networks and external threats, functioning as both firewalls and proxy servers to filter and monitor traffic. MAC layer firewalls operate at the data link layer, making filtering decisions based on the specific host computer's identity, using MAC addresses to control traffic. Hybrid firewalls combine elements of packet filtering and proxy services, or circuit gateways, to enhance security without replacing existing firewalls. They include next-generation firewalls and unified threat management devices. Firewalls can be configured to operate at different OSI and TCP/IP layers, using various protocols to provide comprehensive security across the network. Firewall architectures depend on network objectives, implementation capabilities, and budget. Common configurations include single bastion hosts, screened hosts, and screened subnets with DMZs. Single bastion hosts, often referred to as sacrificial hosts, act as the sole defenders on the network perimeter. They typically have two network interface cards, one for external and one for internal networks. This setup often uses network address translation to add an extra layer of security against external attackers. Screened host architecture combines a packet filtering router with a dedicated firewall, such as an application proxy server. This setup prescreens packets to minimize traffic on the internal proxy and requires an external attack to compromise two separate systems before accessing internal data. The dominant architecture used today is the screened subnet with a DMZ. This setup performs two functions: protecting DMZ systems and information from outside threats, and protecting internal networks by limiting external connections to internal systems. Screened subnets with DMZs commonly consist of two or more internal firewalls behind a packet filtering router. Connections from outside are routed through an external filtering router and into the DMZ, while trusted internal network connections are allowed only from DMZ bastion host servers. Here are some well-known port numbers and their associated protocols, such as FTP, Telnet, SMTP, DNS, HTTP, POP3, and SNMP. These ports are essential for various network services and communications. Content filters are software or hardware appliances that restrict content entering or leaving a network. They use scripts or programs to limit user access to certain networking protocols or internet locations, primarily to restrict internal access to external material and prevent non-business web access or email spam. Protecting remote connections often involves using leased lines or other data channels secured under formal service agreements. Virtual private networks, VPNs, have become popular for securely connecting to an organization's network due to the widespread use of the Internet. RADIUS and TACACS are systems that authenticate users trying to access an organization's network via dial-up connections. RADIUS centralizes user authentication, while TACACS validates user credentials at a centralized server, both ensuring secure remote access. In RADIUS configuration, a remote worker dials into the NAS and submits their username and password. The NAS passes these credentials to the RADIUS server, which then approves or rejects the request and provides access authorization. Finally, the NAS grants access to the authorized remote worker. Virtual private networks, VPNs, use the public telecommunications infrastructure to create secure communication channels. They are commonly used to extend an organization's internal network connections to remote locations, with technologies like trusted VPNs, secure VPNs, and hybrid VPNs. Trusted VPNs use leased circuits from a service provider. Secure VPNs use protocols like IPsec to encrypt traffic over the Internet, and hybrid VPNs combine both trusted and secure technologies to provide encrypted transmissions over a trusted VPN network. A VPN creates a secure tunnel between your device and the Internet or between two private networks. This tunnel ensures that data transmitted over the Internet is encrypted and secure, providing Internet access through a VPN server. VPN tunneling protocols include PPTP, L2TP, SSL, and TLS. These protocols create encrypted links between your device and the Internet or between two private networks, ensuring secure data transmission. Tunneling is a protocol that securely moves data from one private network to another over a public network. It involves encapsulation, which wraps data packets inside other packets, and encryption, which encodes the information so only authorized parties can access it. Remote access VPNs allow business users to connect to a private network and access its services remotely. They are also used by home users to bypass regional restrictions on the internet and access blocked websites. Site-to-site VPNs connect multiple offices of the same company or different companies. One router acts as a VPN client and another as a VPN server, enabling secure communication between different locations. Transport mode VPN encrypts the data within IP packets but not the header information. This allows users to establish a secure link with a remote host, encrypting only the data contents of the packet. Tunnel mode VPN encrypts the entire client package and adds it as the data portion of another packet. This model ensures that intercepted packets reveal nothing about the true destination system, providing a high level of security. Access control determines how systems admit users into a trusted area. It relies on identification, authentication, authorization, and accountability. Firewalls prevent unauthorized information transfer and can be categorized into packet filtering, MAC layers, application gateways, and hybrid firewalls. Firewalls can be implemented as static filtering, dynamic filtering, and stateful inspection firewalls. Common architectures include single bastion hosts, screened hosts, and screened subnets. Dial-up protection and VPNs enable secure remote connectivity over public networks.